What you guys doing?
Phonetically, it'll spell it Prescott.
My question to you is, can you look at the example that we were doing yesterday and ask yourself whether the title above it works or doesn't work?
Oh, it doesn't work.
Doesn't work.
No. That's what I kind of like. Just look at your nose, it'll help you. Really? Really, Kyle, did it help you? Yeah, yeah.
Yeah. Roasted.
Wow.
Is there lunch?
Oh, yeah, good girl.
Oh, right.
Grandma Caroline.
Guys, I really don't like going to
Why
English.
is it not my pages?
I don't like going to Bible. I hate going to Bible.
Why did you hate going to Bible? Bible's amazing.
Switzerland.
No,
What about-
I
what about-
don't want to take an AP.
He's mistaken for Sweden.
Oh my god!
How dare you?
All right, what do you guys think?
Switzerland is the best country to ever be created in the world. Yes.
Doesn't wait? Is it Switzerland that makes the good chocolate?
That's number two.
What?
One of those countries makes chocolate.
All right, Gabby, what do you think? Was the title above our work, Gabby, was the title above our work correct or incorrect?
The title. Wait, what?
Polar.
Uh-huh.
Well, it's rectangle.
We did end up in an equation with y's and x's, but technically,
Yeah, I'm talking.
Oh.
another perspective. Gabby, go.
Okay, technically it is correct, but we can't do this one algebraically and we would need our calculator because everything ended up canceling out.
True, except, where did we start in this example, everybody?
She meant it that way, Gabby.
Oh.
Question, where did we start?
Polar.
Parametric, didn't we?
Parametric.
Yeah.
We started with polar, but then where did we start in our process? We went to parametric.
So
So
we already
technically,
have
if we were trying to get to parametric, where would we have stopped? I didn't want to have to write it all over again. Yes, we could have stopped for parametric,
Like the two cosines.
right? Are those parametric equations? Yes or no? Okay, so I did want to show you guys, we did accomplish something yesterday. We did get parametric equations that we could have plugged in and we could have graphed. We could have graphed it in polar with 2 plus 2 cosine. We could have graphed x equals and y equals. And then we tried to go from parametric to rectangular, we tried to go from parametric to rectangular and it was a mess. Did it work out well to go from parametric to rectangular?
No.
So can we pause for just a second and think about, is there any other way that we could maybe at least attempt how to go straight from polar to rectangular without detouring, taking a stop off at parametric?
Wait, I got so what's the equation?
Oh, this is
R equals 2 plus 2 cosine theta. I think, is that it, guys?
I see the square.
I would scroll up, but my smartboard only works to right now. Fun times.
I know how to do this.
We could use the
Multiply
Pythagorean.
multiply by r.
X squared, Y squared.
We could multiply both by R. You want to do
And
that?
then you get x squared plus y squared, and then it becomes r cosine theta, which then becomes x by r. Yeah. And then you can solve it.
So far, just using formulas, multiply both sides by R. Substitute the easy ones. What am I going to do with the little r? R squared is equal to x squared plus y squared.
Oh, plug in 2 plus 2.
Oh. Oh, r cosine is 1. Wait.
No, but I don't want to get a theta back in. You know what I mean?
Yeah.
R cosine.
Oh, solve for r?
Yeah, solve for R.
R squared equals x squared plus y squared. So what does R alone equal?
Square root.
There you go.
Square root of x squared plus y squared.
Do you guys see why this was so messy when we tried to go from parametric to rectangular?
Yes.
Is this an easy equation?
No.
I'm not so sure. Katrina.
What happened to
Oh,
That's
r
so
cosine
funny.
theta equals x according to our formulas.
Oh, it does.
cosine theta? Would you have been able to like write cosine theta?
Make it x over r.
Yeah.
Then you could have multiplied r on the other side. Is this one variation of what it looks like in rectangular form?
Yeah.
However, did you just hear what Lucy said? It's actually the way I would have gone personally, but I went with the way that you guys said. Kiddos, look at the right triangle. Do you still have it? That relates x and y with r and theta?
Yes.
By multiplying both sides by r, we actually just made it more complicated. Because the same way that we could have plugged in for r from the outset, we could have also plugged in for cosine. Who is cosine of that triangle?
X over R.
Sorry, SOHCAHTOA. Y over r, right?
What?
Wait.
No, cosine is
Isn't
equal
it
to
x
adjacent?
I thought it was
Adjacent
I-
over hypotenuse.
I was writing x over r and I'm like sine. So I said so. I meant
Oh, yeah.
now what? Wait, what if you didn't substitute for r? What if you left r? Can't you multiply r
Yeah.
to both sides now? So I have r squared equals 2r plus 2x. Does it end up being the same thing? So the variation is the same, but was it a different way of getting there? Did both of them end up working? So two different approaches ending in the exact same result. Yeah. Oh, remember our formula from up here? There we go. If r squared equals x squared plus y squared, we could solve for r by square rooting both sides. So technically it's another variation of that formula number 3. Yeah, Gabby.
Is there a way to completely simplify that, or is that like the most?
Nope. It'd be a mess. Well, it would not be fun, let's put it that way. It would not be fun to do it that way. So, question. Is it a wise step to go from parametric to rectangular trying to convert from polar? Probably not. But can you quickly convert from polar to parametric using the formulas x equals r cosine, y equals r sine? Yes. What would be a better strategy going from polar straight to rectangular? Trying to plug and chug as soon as possible for r's and cosines and sines and thetas. Does that make sense, kind of, guys? Okay. What if I wanted you to sketch a graph? Now, the nice thing is we actually practiced this in our summer assignment because you guys had a question on this the second day, first day. So I want you guys to prove to me that you know how to graph a polar equation if I was to give it to you. P.S. What's coming tomorrow?
Test?
Quiz.
Really?
Just on polar and parametric.
Oh, Katrina,
So did you say group quiz?
Can we do a group
In all seriousness, I heard group quiz.
You're hearing things, kid. We got your ears checked.
Was D in the G?
I'm prepared for a group quiz.
I heard group
That would be
quiz.
foolish. Graph. Do you need a polar graph? No. Let's see how accurate the pictures get. By hint, I would start at when the angle is 0.
Wait.
Johnson has a rule.
Wait.
And then cosine is 1/2 at pi over 3. I might even go 0 to pi over 3 and then pi
Alright, who's not taking notes?
over 3. Everybody's taking notes.
What is possible?
I didn't have a notebook, so
But now he's caught up. We're good.
almost.
Ish.
Parametric.
Well, I taught you in chemistry. So I taught you chemistry. Yes. Not that.
It's just completion and you know how to do it.
Oh, wait. Wait, this is. I remember this. Let's see. Isn't that cardio? Or isn't that cardio?
Maybe.
I just remember this. I read it last night. It literally is like thousands. Like
What?
This was
It's a what?
yeah, it was.
I
It was number 11.
I was never.
It was the exact
No, it's
Oh,
similar.
similar. Yeah, we're gonna look at the similarities and then try to make some reductions. Alright, I'm gonna freeze the screen, see if I can beat you. You guys have had way more time than I'm gonna have.
Yay! What?
As far as you need to go.
Oh, it's just
Oh, it sounded the wedding march.
oh.
No?
No, it was.
Um,
Just catch yourself.
how's that look? Ooh, that's not gonna be good.
What kind of angles do you play cosine?
Yeah, I didn't know. Carly, can I just say thank you? You're like adorable.
Cosine of pi over 3 is
Stop it, Kyle.
Double check my values. How are they looking?
It works. I I just fixed it. What happened?
You don't be doing.
It was good for like 5 minutes.
And also when I try
That's
to
fine.
use my finger to select things, so.
I don't see your name on it.
I don't think my.
I feel 1, 2, 3, 4, 5. 13, round. No, that's that.
I only use the pi over 3s because cosine's 1/2, so it was a nice.
Oh, you used to hard.
That was smart, right? If I use pi over 6s, I have decimals and radicals. And
Yeah.
all that stuff. So that pi over 3, I'm going out 1. Pi over
Blessed art
2, pi over 3.
Cool.
Are you not allowed to go into the I got 2 pi as 4.
Oh, yeah, that was what missing.
Oh, that makes a lot of sense.
So remember, 2 pi cosine is 1, so then 2 is 2. You went Yep, this is a cardioid, which is kind of in the limaçon category.
Wait, Misty. Do you need to memorize every shape?
No, if you don't mind making tables.
Oh, dang it.
Can we just make a argument for the ship?
Call it the heart shape.
I like that.
Misty.
I have some pretty clever
It's called
ones.
cardio.
Yeah, it's more like cardio.
Like cardiac.
Is it because it looks like
Cardioid.
There's 2
Cardioid. Kyle.
So last night when I graphed a similar equation, ultimately the graph looks like it formed like 1,000 of like squares, and it formed a cardioid.
What do you mean, thousands of squares? I think that would be plus or minus this one.
Show you.
Yeah. Oh, when you graph it on your calculator.
Yeah.
Kyle, you done this.
Hold on, I'll get it to be all funky on mine. Did anybody try to graph? Well, yeah, you guys had to use your graphing calculators last night, right?
Yes, we
At least a little bit.
I always use that.
This is really hard.
Like, I feel like you guys have like secret conversations.
I say it. Yeah, fishing trip.
Or us after.
You missed out this. It's good. No fishes are coming out. That point
I'm good.
Am I going crazy, Dad?
Why? What makes you think you're going
Because right now it looks fine.
Yeah.
It looks like cardio.
Okay.
Last night it looks like a bunch of squares.
You think you plugged it in wrong?
Oh yeah, we did.
You could have plugged it in.
You don't have to solve it on that.
I did not give it
You
that.
think
It's
you
like
put it
you
in
plugged
wrong?
it in. Oh, no,
Corey? Who else would I be?
Because some
I'm seeing your dilemma.
Just give me the name.
My question to you is, if you were ever to see something like this, what is wrong with the window? Do you see? Oh, hold on.
There we go. Looks like this.
Oh, that was cool. How'd you do that?
2, was it minus?
Yo.
2 cosine? Question. What's wrong?
What?
Oh, I beat you this one.
What?
That's
I don't know.
What's wrong? Where's my cardioid?
First time I'm like,
My equation was right.
really?
What do you mean? What's wrong with my window? I'm in radians.
Go Zoom
See?
standard and figure it out.
In my window,
That is Zoom standard.
Yo, why is this too? It's too big.
why is it too big?
We don't need that many.
Katrina, focus! I'm in radians. My picture is all funky. There were all these little squarey things that happened. My window is 0 to 360 and 5. I don't understand.
Because we're in
Stop, gotta be in degree mode. Go
Try Zoom standard. Yes, I did have degree measurements in a radian mode. Question. Let's go see the window. And my question is, what is different that makes this now a cardioid, whereas before it was a funky, like all kinds of square thingamabobs?
You probably changed it to 2 pi.
Ooh.
So if you ever have a degree window and you're in radians, or a radian window and you're in degrees, hey, what did I do to reset? What I always do to reset. Yeah? Cool deal. It might be a little more fun to do the weird window if you did something like, let's see, what would be something more fun? If you did cosine of like 6 theta, and you were in radian and you went to degree window.
You good? Yeah, this is really messy, but like, I think got it.
Oh wait, hold on, that's not very fun.
It's messy complicated.
Yeah, Kyle. Kyle. Hi. What?
My sister got into the same one as my sister, and she's in like algebra 2.
What do you guys think?
It's a family.
That's cool.
Oh my
Yo.
gosh, it's just a bunch of stars.
What's it supposed to be?
You're treating your star.
I think a road, right?
It's supposed to be a rose with how many petals?
I mean, that looks
5,
pretty cool.
3,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11,
12.
Why? Because it's 6 theta. Whenever you have an even theta, it gets doubled with how many petals? What went wrong? I'm in radian mode, and I have a degree window. But my question to you, why is the degree window bad?
Guys, it's 360.
It's full circle.
It's not bad because it's 360.
The step is 5.
Yes. Why is that a problem?
Because when it's like, isn't it like when it's a large step, it's more inaccurate. Oh my
Is that? I
Don't you go to college?
Yeah. So what step do I need it to have?
Like 1.5.
Let's see. We can try one.
Taking a quiz tomorrow. Is it hard?
Oh.
Well, it's better. I'm actually not sure. Let's see the little smiley face with the nose and face. Anyway.
It's like they're drawing the
It looks like it.
Oh, wait, that's
Yes, thank
Yeah, that's true. I know. That's maybe not a good thing. 0.5 better?
Yes. Oh, no, it's a star.
Lindsay lost it.
Happy about it.
So wait, just give her 10 out of 10.
Because she did do it and it was completed.
Now I don't see it.
Man, I still don't see a rose. Maybe not 0.5. But is it getting better as I go?
No.
No.
I have the one looks pretty good.
0.025.
I mean, one looks better than one.
At least I can see my rose, right?
Oh, this one's much better.
Yeah, see?
I actually like the other one.
So this one's quite well. I know, like the other ones are cool, like if you want to make crazy shapes and whatnot, but I'm just trying to show you the difference. So it's all about the step. Now, oh wait, why is it still going forever?
We're doing 360.
Oh, it's doing 360. It's going to go on forever and ever and ever. But the 360 was not the problem. The step was the problem, right?
Yes.
All right. Let's go back to our, because Kyle, I heard your question about the graphing calculator. Let's go back to our notes. Boop. Cardioid. Could you memorize anytime you have an A plus or minus an A times cosine or sine that you're always going to have a cardioid?
Yes.
Yes, but question, mathematically, how big can cosine be?
Infinite.
1 to 1.
1.
1.
So, if this is maximized at 1, A plus A, the biggest it's going to be is double A, right? And isn't this the biggest it went with was 4?
Yes.
Okay. What's the smallest it's going to be?
0.
Because
Zero.
cosine goes down to -1. -1 times A will be 0. It's going to come into the 0. It's going to come into the cusp, and it's going to come back out. That's cardioid. Now, what would happen? What would happen if my cardboard's still not working when I try to touch it? If don't do a table, think the math. What's going to happen to this guy when I go through and I plug in stuff? The biggest it's going to be
4. 4.
8.
Oh, this next one?
Didn't you just say it was like double? Isn't it gonna be like 6?
So that's like how many petals there are.
I thought that was what
Can
was
it be 4? And the answer is yes. What's the lowest it can be?
1. No, 0. 0. Negative 4.
-2.
Pi.
Wait.
Plug in the highest one, 4. Plug in the lowest, -1, -2. True?
What's the lowest?
Pause. The biggest sign can be is positive 1. So then 1 plus 3 times 1 would be 4. The lowest sign can be is -1. 3 times -1 is -3, plus 1 is -2.
What does max R mean?
Max R is 4. Here's what the max R is for. What if that was a negative and that was a positive? Max would still be 4 because it's the farthest out it goes, even though it goes in the opposite direction. Now in this one, the 4 was positive, the 2 was negative, and the 4 was highest. But with maximum R, what you're thinking is absolute value of R. Does that make sense, guys?
Yes, ma'am.
So I'm going to go ahead and do 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 is down there somewhere. 1, 2, 3, 4. But pause before we do the whole table, plugging in. I get you guys to get some sort of just natural sense with polar. If there is a negative radius, you just saw one that didn't go negative, it went to 0. Remember the cardioid, it went to 0, but it never went negative. Which means as you're going through the angles as you rotate, right? As you go to pi over 3, I was going out. Pi over 2, I was going out. 2 pi over 3, going out, going out. Why was I going out naturally as I was going around? No, because my R's were always positive. So I was going towards the angles in a natural counterclockwise fashion, right? What's going to happen if you're going out and then all of a sudden you're going in?
Oh, negative.
Okay, a negative radius is going to make it go in. Can you guys figure out what kind of shape that would be? What? No, not petals or roses, but you do need negatives to make petals or roses. Not a spiral. Spiral would be something like R equals beta, because then it's always getting bigger and bigger and bigger and bigger and bigger and bigger. And that's why.
Is it the one that's
Not a lemnis gate, that looks like an infinity.
Oh, the snail.
Snail, limaçon.
Snail.
Give me a graph, go.
Question.
You should get a snail, a limaçon.
On the test tomorrow, we're gonna have to know the names of the solar things.
You need a group quiz?
Let a yes or a no, because then I have to learn these names. It's not that I'm just making my own, I'm making little heart.
It's been
Eyes.
3 days and a senior retreat.
Give me a bonus.
The quiz was supposed to be today. Did anybody notice I moved it to tomorrow?
Yeah, I noticed.
This one? Oh, that's what you Why would you know when you talk to Clark? George. She was in my Oh my god! Why are you wearing this khaki shorts? They're short. They're short. But I'm not really school shorts. No, they're not school shorts. Are you wearing socks? No.
Yeah.
We walked through the wall because they're dumb. I told them they need to have an appointment. They're like,
Oh, I was like, did you have Kyle do
I
it?
was like, Grace was like, yeah, just walk in. I was like, okay. And then I tried to walk in, and she was like, no, you need an appointment. What I tell you? So I shot a text to Rich real quick. He was like, yeah, a little bit.
What's up?
So then we walked to Rich. He's like, no, I'm busy. You can't come in here. So they're like, oh, we're going to Dr. Clark. I'm like, I'm not doing that.
Why am I doing it?
You never do it.
I always do examples. I do examples and formulas. I don't take
Oh,
my
you do
notes. I'm
Oh, you
doing
do your
examples. I'm still taking my notes. What?
Okay.
Yeah, I do examples and
Questions? This is a sign. What do you guys use for your angles?
a student page.
Yeah, I would assume.
I did pi too.
That doesn't mean ones are null and void. They're there, but they're decimals, and so it's messy. It's hard to do. You know what I mean? I miss them. 5 or 6, 5 or 2, 5 or 6, 5, 7, 5, 6, 3, 5 or 2, 5 or 6.
Too far.
Oh, I didn't like theta at the beginning.
Dang
Oh. I didn't mess up your table. I messed up my table. Calm down.
Whoa, yo, you can do that? That's so cool.
Oh no!
It's a bit small.
Yes.
It's gotta do the same thing.
No!
Nice. No arrow.
Deal with it.
You can have the zero on the other side.
Oh,
Oh, you
my
could.
God.
Yeah, you put it down on this side.
My
There we go.
God.
There we go.
What'd you get
Going
zero?
backwards.
Yeah, exactly.
What'd you get zero?
1.
How about 5 over 6?
5 over 2.
How about 5 over 2?
Oh, my thing's memorized.
5, 5 over 6. Hi.
1.
7 5 over 6. 2 5 over 2.
0. Oh yeah, it's like
Right?
weird
Because
pies.
negative 1, then negative 2. 11 5 over 6.
These really weird pies.
Don't pass my pie.
1.
Nice.
Who you want?
That was Cody. How does one go?
When does Dylan leave?
That's so hard.
What?
When does Dylan leave?
Tomorrow.
Oh, that's fine.
Yeah.
That makes sense. Plus 1.
He's going to.
When do you leave, George?
I already left.
How's
Got my dorm roommate, everything. It's a girl.
Yeah.
Oh, you're in the rainbow dorm? like at Jared's?
No, that's rainbow.
You mean a housemate or a roommate?
Whatever. They love pets at my dorm.
He's a dog.
Get
Yeah.
a puppy.
I do. Name's
Yeah,
Ishmael.
the puppy.
Dog.
Yeah, do you want to come last one?
Georgie, why haven't you shown me pictures of your dog?
Because you won't like them.
Is it a chihuahua?
No, it's Satan.
That's not your dog. Is her dog? Her dog's
Right, but her dogs are nice.
Oh.
Why'd you draw that?
It's just nice to me.
Oh, it's so nice.
Until I try to grab something.
No, he growls at you too.
Wait, George, when did you
No, he
start?
growls at me.
The 30th.
So I can just like,
We didn't do it.
kiss me, kiss me, kiss me.
5 over 2 is 2.5, right?
Yes.
You guys know I'm drawing that semicircle or quarter circle?
Yes.
Get it.
Yeah.
Wait, this is mine now.
Oh, I have that.
We were using like normal coordinates and one of
Wow, you have a competition book? Wow,
Why?
Yeah, chill.
what?
I'm Kyle.
I just gave you my notes. My notes.
For the whole thing, we would do one word. And we would do like one word, but she didn't really like
Oh, I didn't think it.
like pi over 2.
Because now that we're doing polar, remember it's R two things, so the R's will be normal measurements, but the betas I'm doing ratings. So I was doing degrees, I did 45 centimeters. But in polar, if it was like 1 1, those would be X's and Y's, and we would be converting.
To get it like R and Z.
Okay, I'm down to the negative 1. 7 pi over 6. How do I go negative 1/2?
Backwards.
Go backwards from 7 pi over 6.
And then negative 2. And then negative 1/2. And then 1. So how does it look?
Oh, this little Snoopy thing? Yeah.
Limaison.
Oh.
Or you could do like a mushroom.
She doesn't yell at me.
And this one is called a limaison.
Because it looks like a lemon.
Good job, Kyle.
Well, there's like 3 different
When
kinds.
will there be a limaison?
When there's a little loop inside of a loop.
When the thingy
Oh.
goes negative.
When A.
When R is negative.
That's the way it's formula.
Oh, when the first A is smaller than the second A.
When the first coefficient, yeah, is smaller than the second coefficient. When A is less than B.
Wait, this D? So there's like 3 different kinds of this.
Well, I call a limaçon the one that has like an actual going in, technically the whole category of limaçon. But I like the ones that come into a cusp. I like the better or the more detailed classification of cardioid. So I would call those a cardioid. You have the dimpled, you could call it a dimpled limaçon. This is a limaçon with an inner loop. Specifically. With an inner loop, yeah.
Jesus Christ, that A should consider beating this cardioid.
Oh, I got it. It's the exact same thing, but the coefficients are the same. So I have A.
Is there a cardioid whenever A and B is the same, so it's A?
And if A is, well, you guys answer, some of you might be in the book, some of you might not be, but if A is greater than B, will it go in on itself? Will it go negative?
No.
No. Will it even go to 0? So it's going to go, and then it's going to flatten, kind of like, hey, look, illustration, it's nice calculating. What? Oh, he doesn't even go flat on the bottom. Kind of like a Will that goes flat, but he doesn't, so that's a horrible illustration. Yeah. Hard boiled eggs cold, like egg salad, but not almost with that stuff. Yeah.
Should we go to the previous example for 10 seconds?
Huh?
Previous
Yeah.
example for 2 seconds.
Dun-dun. So when the coefficients are the same, it's going to be a cardioid and come into a cusp. When the second one is bigger, but guys, hold on. What did we do to figure this out? Plug in when sine and cosine is 1. Plug in when it's -1, and think about it. Does the R go what?
Negative.
Negative. If it goes negative, what is it going to have? An inner loop.
Inside.
It's going to go in on itself. It's going to have an inner loop. If it goes to 0, it's going to have a cardioid. 0 and not negative. If it doesn't go to 0, then it's not even going to go in at all. All right, cool kids. You're supposed to work on homework. Let's go ahead and see what questions you have on parametric and polar.
72 and
72.
39.
Starting with parametric.
No, polar.
Just do polar.
Okay, parametric. We're good. We'll go back to polar.
Oh,
Can you-
I didn't know how to do 28 through 32 on parametric.
28 we do?
It's 29.
Oh, 29 through 32.
Oh, Carolyn.
How could you forget Caroline?
I just forgot.
Where's the love?
Right beside? No, it didn't. Because of the thing. I don't know the things. I didn't
Well,
even
I would never forget that.
You avoid Cody Bow.
You would get all the You would get all times. I would never forget.
Okay, question. Someone is wondering how to do 29 through 32.
Katrina.
Just because this is good.
Someone has answered, but who?
Kyle can
Yes,
answer.
I do.
We have parametric equations, x equals y equals. We have a t interval. We're trying to figure out which t's will get to which quadrants. No, go.
I go up there. Oh, you want the answer?
Oh, just explain how you did it.
Oh, yeah. So I made table,
Yeah, that's what I probably said too.
and I plugged in like it's kind of weird how I did it because I made a table, put in like the points that they went from like -5 to 3, and I saw that which points slide in each quadrant, so I just grouped them together.
Oh, okay. So he did the table, he looked at all the different values, and he figured out which ones were which quadrant. Long story short,
Strategic.
you didn't even necessarily have to make a table. You could, and you probably should, but if you plugged in -5, well, long story short, 5 is greater than 3, right? So the x is going to be a negative. So the x is negative here, and the y, if I plug in -5, is also a negative. What quadrant am I in? I'm right here, right? A negative x and a negative y. So figure out how much longer that's going to go for. So if I plug in -4, still negative. Plug in -4, still negative. -3, no longer, right? So I know right away from, where's quadrant 3? From -5 to -3, but not including -3, right? T is within, sorry, I didn't put T's. So -5, -4, -3.1, still it's going to be in the third quadrant. However, starting at -3, well now where am I? Well that's going to be 0. That's a 0, that doesn't count. What if I was to go -2, right? That's going to be a positive x, so now I'm moving to the right, and then -2, that's a negative y, so over to the right and down, now I'm in quadrant 4. So -2 is in quadrant 4. -1 is in quadrant 4, still positive negative. 0 is in quadrant 4, because that's still a negative y. But as soon as I get to 1, no longer quadrant 4.
Good.
You plug it in.
Negative 1, 0.
Or you look at intercepts.
I guess -3 is
Yeah.
on an axis.
Thank you.
Because x is 0, so maybe I should leave it
Can't you
open.
just look at the
Yeah, you
intercepts?
look at intercepts.
Yeah, can't you just look at the intercepts and just plug those in?
Yeah, that's what I did.
Yeah, that's what I did.
But how does it help you with the t's though?
Teas?
Oh, you solve for t.
Yeah,
Yeah, you solve
Ah.
for T and then you just plug in the intercepts.
Wait,
and that's what
I
it
was
is.
going with Noah's experimental way.
Ours is faster.
Hey.
Easier.
Their way of saying, hey, you can plug in and see that this is 0, 2. You can plug in and see that this is 0. Is it -4 or -3?
Wait, what is the?
You're just looking at
Maybe
it.
that.
-3 or 4? And you figure out this one is at 2, 0.
I stared at it.
So you could say, what makes y equal to? What makes y equal to? You guys see that?
Because I picture the intercepts and
No,
find what value of t makes those. You have the x
No,
and y
not.
equal. And you know the intercepts. So you have to find what t's.
Okay.
Well, like you have the intercepts.
And-
So you have to say 0, 2.
Choose to check on your success.
So I think
Huh?
0. So
Check
0
on your
equals
success.
Or lack of.
So
Yes, that's a what?
Genius.
What is she?
She teaches ESL.
What's ESL?
It's a second language, so any students who are coming from different countries that haven't developed English skills, she's helping them, but then she's also helping Mr. Richmond just check in and make sure that the international body, like student body community is doing well.
Nice.
So she's checking in with all the medical years just to check in.
HBC was perfect.
Okay, that's why she sent him back. She doesn't know them all yet.
Oh.
No, it's not a citizen.
Anyway, do you guys get the idea?
Yo, we can.
No, I'm saying like.
Pause. Wasting time.
Are you just plugging in
I'm
numbers?
plugging in T's and I was just seeing what quadrants, and then when it moved to a different quadrant, then I went ahead and figured out what quadrant that was and kept going. What they wanted to do was see what the different intercepts were and say, hey, when y equals 2, it separates the higher y's are in the second quadrant, the lower y's are in this quadrant, so they plugged 2 in and they solved. So y equals 2 when t equals 3, so they knew that 3 was a divider point. Same thing here, plug in -4, which is at -5. They knew -5 was a divider point. So they were finding the divider points. I just went to the table like Noah did, and I figured out where the points were grouped by the quadrants. Does that make sense? Guys, long story short, we finished the parametric section for the most part.
Yeah.
Okay. So we're on the polar section. We have a few questions. We did go over. I know the bell's about to ring. In the polar section, you guys remember, or you had a few questions last night. Why don't you go peek at it one more time? Come tomorrow with questions. I'll see how long the quiz is. I don't think it's super long. We'll probably be able to cover a couple of your homework questions. Unless you come into 0 period in the morning, we don't have to worry about it. Anyway, well, I will take 10 minutes at the beginning of class to talk about polar homework and whatever questions you have instead. Tomorrow, have your graphing calculator, but also be prepared to graph it by hand using the unit circle. And
First one
table,
out every day.
color, and parametric. Okay? Just a
Go to the
quick,
best class in the world.
not super long, so that we can separate review from unit.
Jason.
Right. Pre-cal from CalcBC. I'll say that much. Lucy, did I answer your question okay? Did I answer your question?
Yeah.
Do you not remember what I had? I couldn't